Okay.
Good evening. This is Rodney Carter, President of Suncap Energy, located in Saskatoon, Saskatchewan. I've been asked here tonight to give you a description of and give you some ideas of what LED lights are all about. The advantages, disadvantages, why you want to do the investment in LED lights. So I wanted to start out by asking what are some of your concerns about lighting? You know, for some people it might be the obvious cost of the electricity to run those lights. How hard it is to change the lights? You know, you get into some people's forays and they're up there, they're way out of reach. It's a really inconvenient, it's a task. And that. Recycling the lights once they're dead, like compact fluorescence. How about the light quality? Or the pollution from generating electricity, and all these different ways that might concern you as a user of lights. But I want to introduce myself a little bit more so you understand. My background is electronic engineering technologist. I have an interest in photography, so lighting is critical for photography. I've taken interior design classes and actually worked for a lady doing blinds at one point. I also worked at a custom cabinet shop, so knowing where lights work within the cabinets and stuff like that is all the extra experience that I can bring to the table to help out. Before I started my company up, I did some research into different alternate energies. I even did some hydrogen gas research and decided to go on with some solar energy stuff. And I also did some training. I did a solar thermal installation, but it's pretty messy when you have to start filling the antifreeze into the system and that. So okay, let's move on to the next, right? And the solar electric was my next target because it's closer to my electronic background, so it would be easy for me to migrate into that. But the cost of solar panels are so expensive right now that it's a, you know, down the road that's the second stage of my plan. But I started doing the math and it was, well, change the lights to LED lighting first, because the payback time is a lot faster. The other thing with going with LED lights, then you don't have to worry about the sun shining, the moon, or the wind blowing, or you don't have to deal with the neighbor's trees shading your solar panels, or even in my own house, my roof is oriented in the wrong direction. So it would be very hard to get the panels, and they would be at all kinds of angles, and it wouldn't look very aesthetic in that. So again, getting back to what the lights are, because everybody needs lights. Save 24 hours a day. Whenever you use them, you're saving energy. The other part of the math was, if you take a 60-watt bulb and you want to run a solar panel on it, let's say it's $5 a watt for a solar panel, it's going to cost you $300 just in solar panel to run this one bulb. By you changing over to a 7-watt bulb, same amount of light, it would only cost you $35 for that solar panel system, plus $30 for this, $65 solution versus the $300 solution. What's your choice?
Makes sense.
Right? The problem we have in our society is we're actually addicted to light. We operate 24 hours a day all around the world. We need lights for work, play, security, safety. And then there's even all the lights that go into the entertainment environment, right? Stage shows and stuff like that. And as we get older, we need to actually double the amount of light that we need so that we can read the fine print on labels and stuff like that. So nothing we can do about that, but we need to have more light, right?
Right.
So the most common solution for all these lighting is the good old incandescent light bulb. This bulb, this technology, was invented in 1879. Okay, so things have changed in that amount of time, right? And the good news for some of us, bad news for other people, the incandescent bulb is actually going to be phased out of production in 2012, which now is 8 months away, and so you won't be able to buy them anymore. I guess, well, other countries have banned them already, and the way they're producing them yet, it's a heating bulb, it's a heating element. So that's how they do it, yeah. And there's all kinds of other technologies that have evolved over this timeline of 1879. You know, there's the high pressure or low pressure sodiums, there's mercury vapor, there's metal halides and high bay lights in warehouses, and there's also the halogens that we're all used to in our houses. But all these technologies, all these type lights are based on heat. By passing electricity through a special material, the material heats up and glows, emitting the light that we see. But along with that is all the heat that comes with it. Right? And then the other technology that we're so common or used to is the fluorescent tubes and the compact fluorescents, the CFLs. One of the things with the compact fluorescents is now people are putting them into the reading lights, which are very close to them. And there are people with some very sensitive skin that they end up with a rash. And if you were to Google 16 by 9, that's 16x9, it's a production on TV. And so 16 by 9 CFL, and you'll see 2 episodes talking about how this is affecting people with the compact fluorescents being so close to us. I'll explain why a little bit later here. The other thing, sorry, hyping on compact fluorescents, but that's part of my mission and my job is to help the environment. And there's such a push on compact fluorescents right now, and trying to make people aware of the dangers of compacts. Because even a good quality compact fluorescent, when you throw it out, which probably 95% are going to the landfill instead of getting recycled properly, each one contaminates 1,500 gallons of drinking water. Right? So the cheap ones that people are buying in the stores, they're probably good for 5,000 gallons of water. You know, so think about 5,000 gallons of water times 95% of the lights going to the landfill. It's not a good thing. And are you aware of what you have, the cleanup procedure? No. If one breaks in your house? Okay. The Environmental Protection Agency in the States says, open all the windows, evacuate for 15 minutes, then come back in and start to clean up.
What about Canada? What does Canada say?
Well, it's based on the principle, it's still dangerous, right? You know, I've seen some other ideas of how to clean up and that, so I've got some little notes here for you. Open the windows, evacuate for 15 minutes. Then you should put on gloves and a mask, because it's the vapor that's coming off, right? You want to pick up the broken pieces of glass and put it into an airtight bag or a container. Then they were saying put tape around your glove with the sticky side out so that you can pick up the little fine pieces. Again, throw that into the container. And then I'm suggesting to use a wet cloth to wipe up, and again, throw that in the container. But you don't want to use a vacuum cleaner because you're going to be sucking up and spreading all of that contamination all over the whole house now. So the wet rag is what I thought would be a really good way to do it for dealing with a broken compact fluorescent. How do the LEDs actually work? They are actually a solid state device built on the same technology as TVs, radios, computers, everything. It's a piece of silicone. It's a solid state device. The white LEDs that we're displaying tonight are actually based on blue LEDs. And it's when the blue LED was invented in 1995 that white was the next stage. And to accomplish white, you put a phosphor over top of the blue, and it's this phosphor that gets illuminated or excited and gives us the full spectrum of what we perceive. Okay? So the more phosphor, more coating you put on, that affects the color temperature and what color we perceive. But it also drops down the amount of light that you get out of the light. And I can show you, if you ever look at a light when it's turned off, the LED, you can see that it's got a yellow base on it, and that's that yellow phosphor. Okay. The one caveat of all this is you're filtering out that blue, but there's always some blue light that comes back in that still gets through, and that's where a cool white has more of a bump in the spectrum. We have a close up here. Like the human eye actually has a bell curve sensitivity to the rainbow of the spectrum. If you have a cool white, then you have more blue not being filtered out. When we get to a warm white, they're able to actually filter out more blue. What I just explained about having the phosphor being excited by the light source itself, that's actually the same way fluorescent lights work. But the in fluorescent lights,